What if you could tour the entire universe in the time it takes to finish a cup of coffee? Stick around, and we'll unpack Stephen Hawking's cosmic bestseller in plain English. 1. Why this book still matters. Imagine a book that sold more than 10 million copies despite discussing quantum mechanics, black holes, and cosmology, topics most people found terrifyingly complex. Published in 1988, A Brief History of Time hit the Sunday Times bestseller list for a record-breaking 237 weeks, proving that everyday readers crave big ideas when they're told with clarity and awe. Why does it still matter? First, Hawking made cosmology conversational, shrinking the gap between ivory tower research and living room curiosity. Second, the book arrived just as personal computers and the Hubble telescope were opening fresh windows on the universe, so it captured a unique moment when public imagination and scientific discovery collided. Finally, its arguments about the nature of time and the origin of the universe continue to anchor modern debates about multiverses, quantum gravity, and the elusive theory of everything. Reading it today feels like opening a time capsule of scientific optimism. Yes, newer data from satellites like Planck have refined several numbers, but the conceptual scaffolding Hawking builds, from the Big Bang to imaginary time, remains foundational in physics textbooks. If you've wondered why pop culture explainer videos reference singularities or light cones, chances are the trail of breadcrumbs leads back to these 200 pages. In short, the book's enduring significance lies not merely in what it teaches, but in how it invites us to keep asking bigger, bolder questions about our place in the cosmos. 2. Untangling the big questions. At its heart, A Brief History of Time attempts to answer four monumental questions. Where did the universe come from? Why does it look the way it does? How will it end? And, sneaking in through the back door, what does all of that imply about our own existence? Hawking guides readers through the intellectual toolkit we need to address those questions. Newton's laws, Einstein's relativity, quantum mechanics, and thermodynamics. He starts with the expanding universe revealed by Edwin Hubble and quickly shows how general relativity predicts either eternal expansion or eventual collapse. From there, he introduces the concept of singularities, regions where density and curvature go infinite, and explains why black holes are the cosmic laboratories physicists love. The famous no hair theorem and Hawking radiation make their cameo, revealing that black holes aren't completely black. They slowly leak energy and information, a mind twister that still fuels research papers today. Perhaps the most challenging but fascinating detour is Hawking's use of imaginary time. By rotating the time axis into the realm of complex numbers, he shows how the universe could be finite but without boundaries, like the surface of a sphere. That mathematical sleight of hand allows him to dodge the philosophical bullet of a first cause, suggesting the universe might be self-contained and need no external creator. Throughout, metaphors, raisins in rising bread, ants on flat sheets, keep abstractions grounded. The result is a narrative that feels less like a lecture and more like a cosmic detective story. 3. Strengths, surprises, and critiques. Let's talk strengths first. Hawking's writing voice, humorous, candid, occasionally self-deprecating, transforms grandiose math into approachable conversation. He famously vowed to include only one equation, MC2, because each additional formula would halve the sales. That editorial discipline forces him to rely on intuitive imagery, making complex horizons, wormholes, and quantum fluctuations feel almost touchable. Another strength is the way he frames scientific progress as a human adventure. Anecdotes about Galileo's house arrest, Einstein's patent office sketches, and his own motor neuron disease ground celestial questions in personal resilience and curiosity. When Hawking jokes that he bets on black holes at poker games with fellow physicists, the universe suddenly feels like familiar territory. Yet the book isn't flawless. Its brevity can sometimes be a double-edged sword. Concepts such as the path integral formulation or uncertainty principle are introduced briskly. Readers without prior exposure may need to pause, rewind, and Google. Later editions include updates on string theory and the cosmological constant, but some sections read like snapshots from the late 1980s, before dark energy reshaped cosmology. There's also the philosophical elephant in the room, Hawking's cautious but undeniable flirtation with determinism. While he ultimately leaves space for free will by championing weak determinism, critics argue that the discussion oversimplifies centuries-old debates. Still, the fact that a 200-page paperback can ignite arguments among physicists, philosophers, and theologians alike is less a flaw than a testament to its power. 4. Who should read it, and final takeaways? Is A Brief History of Time still worth reading if you can already binge a dozen space documentaries on YouTube? Absolutely. And here's why. Documentaries distill conclusions. Hawking invites you into the messy, exhilarating process of discovery itself. If you're a student on the cusp of choosing a STEM major, the book is a gateway drug, offering just enough rigor to spark obsession without drowning you in equations. For professionals in non-scientific fields, it serves as a mental palate cleanser, a reminder that the universe is bigger than quarterly reports and traffic jams. Audiobook fans should note that Hawking's own mechanical voice, while iconic, can be tough for long stretches. I recommend reading a physical copy alongside diagrams, or even the illustrated edition, which adds visual context to concepts like event horizons and cosmic geodesics. My biggest takeaway after revisiting the book in 2024 is its underlying message of humility. Hawking reminds us that every model, no matter how elegant, is provisional. The next observation, the next particle accelerator, the next James Webb image could flip our cosmological table. That mindset isn't just scientific, it's a life philosophy. Stay curious, stay adaptable, and never assume you've arrived at final answers. So whether you're chasing an intellectual adrenaline rush, curating a classics shelf, or simply wanting dinner party conversation starters that go beyond movie spoilers, this slender volume earns its place. Give it an evening, and it might just widen your lifetime. If Hawking's ideas sparked your curiosity, smash the like button, subscribe for more deep dive book reviews, and comment which science title you'd like decoded next.